Good morning. So today I will talk about section 12.6. So section 12.6, we're going to follow the PowerPoint which is available for you on Canvas, and we will be talking about solving system of nonlinear equations. So here we're going to use the substitution and elimination method the way we learn it with section 12.1. However, the equation which you're going to see, they won't represent the straight lines. We can have quadratic equations, we can have circles, hyperbolas. So we may have, we're still going to look for point or points of intersections, but it will be different. When we were solving system of linear equation, when we had solution, it was 1 point, because two straight lines only can intersect at 1 point. Here we may have different type of the equations, let's say circle and parabola. So they can intersect at 4 points. So you may expect to see more solutions. And so the first example which we're going to solve is solve system of nonlinear equation using substitution method. Okay, and I will use the first example from PowerPoint, and I will explain it how to use substitution method to solve the given system. Okay, so let's move on to OneNote, and we're going to work on example 1. We have 3x minus y equal negative 2. This is equation 1. And 2x squared minus y equals 0. This is equation 2. So in this system, equation 1 represents straight lines, and the equation of a straight line, equation 2, represents the parabola. Okay, so substitution method. So what we're going to do, we're going to start with equation 1, and which is 3x minus y equal negative 2, and let's solve this equation for y. Okay, so we're going to solve this equation for y. So I will subtract 3x from both sides. We have negative y equal negative 3x minus 2. Divide each by negative 1. And we're getting y is equal 3x plus 2. So that's what we end up with equation 1. We just rearrange it and solve for y. And now what we're going to do, let's work with equation 2 right now, which is 2x squared minus y equals 0. And we're going to replace y from equation 2 with 3x plus 2. Okay, so we're going to plug in here 3x plus 2. Okay, so we have 2x squared minus, since y is expression, so put that in parentheses, so that will be 3x plus 2. Okay, and follow the rest of equation 2 equals 0. So we have 2x squared, let's distribute that minus to each. So we have 2x squared minus 3x minus 2 equals 0. And like you guys see, you end up with quadratic equation. So let me see if we can factor this quadratic equation. A equal 2, B it's equal negative 3, C it's equal negative 2. So let's see if I can use AC method for factoring. A times C it's equal to 2 times negative 2, which is negative 4. Now let's see if we can find two integers which by multiplication gives you negative 4, and exactly the same integers by addition should give you b, which is negative 3. Okay, so this is b. So let's see what's going to work. Negative 4 and positive 1 will work. Okay, So let's create the factors. Don't forget that this quadratic equation has a equal to. So when the leading coefficient is different than 1, you want to start with building temporary factors. So temporary factors, you put in 2x in each parenthesis. And the first number which we find it's -4. And the second which we find it's +1 equals 0. Now this is temporary factor. So now when you have the case when the leading coefficient again, it's different than 1. So you want to check if you can factor GCF from any of the parentheses. From the first parenthesis, we can factor greatest common factor, it's 2. So let's factor that 2 out. So we have 2 times 2x divided by 2 will give you x. -4 divided by 2 will give you -2. So when you factor that GCF, I teach you that method, that algorithm, you're just ignoring that. From the second parenthesis, you have 2 and 1, so there is no greatest common factor, so we just leave it the way it is, 2x plus 1 equals 0. So now that's the correct factors, again, x minus 2 times 2x plus 1 equals 0. If you want to check, you can check. If you will FOIL that, you will end up with our quadratic equation. Now, when we have two factors, we're using zero product property, which means solve each parenthesis for 0, make it each parenthesis equals 0. So we end up with x equal to, and from this one we end up with x equal -1/2. Okay, so now we're going to say that when you have 2x, so that means you have two different x coordinates, you already should think that this system will have 2 points. So the parabola and the straight line will intersect at 2 points. So we'll have two solutions. Again, don't forget that this is possible because we're solving system of nonlinear equations. So now when we have x equal 2 and x equal -1/2, we're going back. Don't forget that we know that y is equal to -3x plus 2. So now we have to solve for y. Y is equal to 3x plus 2. Okay, so we know that y is equal to 3x plus 2. So I need to find the y coordinates for each x. So let's just separate them. So here we'll have that y equal, replace x with 2. So we have 3 times 2 plus 2. We're having y it's equal to 6 plus 2, which is 8. So the first solution will be point x comma y, which is 2 comma 8. So that's the first solution. Now we will do the same work when x is equal to -1/2, and that -1/2 you replace with x from the equation when y is equal to 3x plus 2. So we have y is equal to 3 times -1/2 plus 2. Y is equal to -3/2 plus 2. So y is equal to -1.5 plus 2. This is 1/2. So the second solution is the point, again, x comma y, which means -1/2 and 1/2. So we have two solutions of that system, 2 points of intersection. So how that looks on the graph, so I use substitution method. Let me go back to PowerPoint. Okay, I'm going to skip graphing, but your PowerPoint shows you okay, so your PowerPoint shows you, again, I mentioned to you guys that we had straight line 3x minus the graph in blue, 3x minus y equal -2, it's equation of a straight line, and the pink graph 2x squared minus y equals 0, it's a parabola. This is the equation of quadratic equation. And like you guys see, we end up with those two graphs intersect at 2 points, which are our solution. So we have negative 1/2 and 1/2 as the first point, and the second point, which is the point of intersection, was 2, 8. Let me just, okay. So, okay, let's continue. So that was example 1. So we're using the same technique which we learned to solve system of equations. You can always check your work. So the PowerPoint which you guys have, it shows you how you can check work if you're not sure if you solved it correctly. Now I'm going to move on to the next example, solve system of nonlinear equations using elimination method. So the next example, here the PowerPoint, which I'm on slide number 10, shows you that we'll have 4 solutions. We're going to have an equation of a circle and equation of parabola. And like you see, those two graphs will intersect at 4 points. So our system will have 4 solutions. So how are we going to solve that algebraically? So we're going to solve example 2. Like you see, the first equation is x squared minus y squared equal 4. It's hyperbola. Okay, so that's equation of hyperbola. Hold on, did I skip any problem? I just want to make sure that I didn't skip anything. No, we good. So I'm sorry, this is just a figure. They just shows you. It has nothing to do with our next example. I got a little confused. So here, this is a different example. So we have hyperbola, and we have parabola. Okay, so let's solve this system. Okay. Okay, so here I want to show you how to use the elimination method. However, substitution will work perfectly, but let's just use that elimination method. So we have equation 1, hyperbola, and parabola equation 2. So the first equation, x squared minus y squared equal 4. The second equation, I will rearrange a little bit. I will move that x squared to the left side. So we have okay. So equation 2 I'm going to rearrange, so that will be, I'm moving x squared to the left side, so that will be negative x squared plus y equals 0. So I'm doing that because I want to show you how you can use the elimination method to solve this system. So I'm adding 2 equations together, x squared cancel, and we end up with negative y squared plus y equal 4. So we end up here with equivalent equation, which is quadratic equation. Let's solve this quadratic equation. So we're going to move everything to the left side since it's quadratic. So I'm subtracting 4 from both sides, and we have negative y squared plus y minus 4 equals 0. I don't recommend it to solve quadratic equation when you have negative number in front of y to a second power. So to avoid that, you want to divide all by negative 1. So I divide each by negative 1, and that will give me y squared minus y plus 4 equals 0. And let's see if we can solve that by factoring. A it's equal 1, b it's equal negative 1, c it's equal 4. So AC method, a times c will give you 4, Now find two numbers which by multiplication give you 4. The same two by addition should give you b, which is -1. Okay, nothing is going to work. So I'm going to solve the system using quadratic formula. So AC method doesn't work. That doesn't mean that this quadratic equation can't be solved. If you can't factor, try quadratic formula. So I'm going to solve it with quadratic formula. Y equal -b plus minus square root b squared minus 4ac, and everything has to be divided by 2a. Okay, so we have y equal -b. So again, a it's equal 1, b it's equal -1, c it's equal 4. So we have -b, which will be 1, plus minus square root b squared, which is -1 squared, minus 4 times 1 times 4, and everything divided by 2 times a. So we have 1 plus minus, from under square root we end up with 1 minus 16, and everything divided by 2, and that will give us 1 plus minus square root of -15 divided by 2. So look what happened. Here, the discriminant, which is the expression under square root, which we call discriminant, it's negative. So since discriminant is the square root of -15, this quadratic solution, this quadratic equation, has no real solutions. Again, you cannot take the square root of negative number, that's why. So the system of equations is inconsistent, which means has no solution. What that means when you will graph it? That means that those graphs will never intersect. So let's go back to PowerPoint and see if they graph that for us. Okay, so we on this example. And exactly this is what you see. The pink graph represents the hyperbola. Equation of hyperbola is similar to a circle, but instead of plus, you have a minus. And the blue graph represents the parabola. And like you see, those two graphs don't intersect. That's why the system has no solution. There is no point of intersections. Okay, so you can see that on the graph. So when you will be working with your homework assignments and you end up you're solving quadratic equation, you can't solve it, or you end up with something what I end up with, like a negative number under square root. That means your system has no solutions, no point of intersection. Next one, let's solve another example. So this is example 3. Okay. Okay, so let's just put that. So example 3. So we have 3xy minus 2y squared equal -2. This is equation 1. 9x squared plus 4y squared equal 10. Equation 2. Okay. So here I'm going to use the elimination method. Okay, and my plan is to eliminate y. Okay, so let's eliminate y. So in order to eliminate y, the second equation has 4 in front of y squared, so we would like to have here, instead of -2, we would like to have -4 y squared, so we can add the equation and the y will eliminate. So how are we going to do it? To get that -4, we will multiply equation 1 by 2. Okay, so here the plan is multiply equation 1 by 2. So the left side you will multiply by 2, and the right side you will multiply by 2. So let's rewrite the system. So equation 1 will become 6xy minus 4y squared equal -4. And then the second equation, it's 9x squared plus 4y squared equal 10. So now we adding equations together. We're using that elimination method. Y squared cancel. We have 6xy plus 9x squared equal 6. Okay. So now again, look what happened. We used that elimination method, but our equivalent equation still has two variables, x and y. So when you have something like this, use the equation and solve for one of the variable. So definitely it's easier to use this equation and solve for y because x is being bring it to the second power. So I'm going to solve this equation for y because it's just easier to solve it. Okay, so we're going to solve this equation for y. So I have 6xy equals 6 minus 9x squared. So I move that 9x squared to the right side. And to solve this equation for y, I need to divide each by 6x. Okay. So when we're doing this, we have to give the condition, since we divide by x, we have to give that condition that x can be equal 0. Other than that, we won't be able to do that operation. So that will give us that y, it's equal 6 minus 9x squared divided by 6x. We can reduce it a little bit, so let's just factor from numerator 3. So that will be 2 minus 3x squared divided by 6x. And then we can reduce a little bit. 3 divided by 3, it's 1. 6 divided by 3, it's 2. So that y will be equal 2 minus 3x squared divided by 2x. Okay. So we have equation of y. So what we're going to do next? Next, when we have equation for y, so we want to use either equation 1 or equation 2 and replace y from this original equation with the expression of 2 minus 3x squared divided by 2x. I'm just checking which one will be better. I think I will use equation 1. So now go back to original equation 1. So like you guys see, I start with elimination and I continue with substitution. Go back to original equation 1. So original equation 1 is 3xy minus 2y squared equal -2. And we're going to replace y. Let me see. I need to do that twice. You know what, guys? I will go back to original. Just trying to see what will be better for you. I will go back to original equation 2. So we will have to do that substitution only once. So equation 2, it's 9x squared plus 4y squared equal 10. And what we're going to do, we're going to replace this y with the expression 2 minus 3x squared divided by 2x. So we plug it in. Going to use the substitution. Okay, so we have 9x squared plus 4. We're going to replace y with 2 minus 3x squared divided by 2x. Bring everything to a second power equal 10. Okay, let me see if I copy the equation to correctly. 9x squared plus 4y squared equal 10. Okay, so let's do work. Okay, so this is pure algebra. So let's play with that equation. 9x squared plus 4. Before you distribute 4, you need to bring numerator to a second power and denominator to a second power. You have to distribute that exponent. So that will be 2 minus 3x squared to a second power divided by 2x bring to a second power, and that's equal 10. So we have 9x squared plus 4, 2 minus 3x squared to a second power. So this is the same again. Let's show work on a side. 2 minus 3x squared to a second power. You can FOIL. This is 2 minus 3x squared times 2 minus 3x squared. So when you FOIL, you end up with 4 minus 2 times 2 times 3, which is minus 12x squared plus 9x to the 4 power. Okay, so that's what you end up with the FOIL. Okay, or you can use the formula a minus b to a second power, which is a squared minus 2ab plus b squared. I like to use this one. You have the square of difference. Okay, so from numerator, I end up with 4 minus 12x squared plus 9x to the power of 4. On the bottom, we're having 4x squared, and that's equal 10. Okay, getting closer. So now we have 9x squared plus, and when you have number multiplied by fraction, that number you put in numerator. So this is 4 times 4 minus 12x squared plus 9x to the power of 4. Everything divided by 4x squared equal 10. 4 and 4 cancel. And we have 9x squared plus 4 minus 12x squared plus 9x to the power of 4 divided by x squared equal 10. Okay. So I think the best way to solve this one will be by multiplying. Like you see, you have fractional rational expression by multiplying left and right side of this equation by x squared, so at least we can remove that fraction. And of course, we gave the condition before that x cannot be equal 0. Okay, so now to solve this one, we're going to multiply all by x squared. Okay, so we multiply the left side of this equation by x squared and the right side of this equation by x squared. Okay, so x squared, we're going to distribute that x squared to each. Okay, so that will be 9x squared times x squared will give you 9x to the power of 4. Now x squared times entire of that fraction, x squared cancel, but let me just show you this is x squared times 4 minus 12x squared plus 9x x to the power of 4 divided by x squared, and like you see, they cancel, equal 10x squared. So let's simplify. 9x to the power of 4 plus 4 minus 12x squared plus 9x to the power of 4 equal 10x squared. Next, what we're going to do, we're going to have quadratic type of the equation. So let's just move all to the left side. So I'm going to subtract 10x squared from both sides. Okay. So on the right side, we have 0. Now let's combine like terms. I have 9x to the power of 4 plus 9x to the power of 4, which is 18x to the power of 4. Now we have negative 12x squared minus 10x squared. That will give us negative 22x squared plus 4 equals 0. Okay, let's reduce that. We can divide each. We have 18 and 22. We can divide each by by 2 only. So divide each by 2 to reduce it. So we end up with 9x to the power of 4 minus 11x squared plus 2 equals 0. So we already know how to solve those type of the equation. This is quadratic type of the equation. So we're going to use the substitution here and replace always the middle one, which is x squared with t. So again, x to the power of 4 is the same as x squared squared, so that will become your t squared. Okay, so we're building equivalent equation, which will be 9t squared minus 11t plus 2 equals 0. Let's see if we can, just give me a second, I will double check if that can be factored, or if not, we'll just move straight to quadratic formula. So let's pause. Okay, so we continue. So this is correct. We can factor that. So let's use AC method. A it's equal 9, B it's equal negative 11, C it's equal 2. So A times C, it's 9 times 2, which is 18. So let's find two numbers which by multiplication gives you 18, and the same two by addition gives you B, which is negative 11. Okay, don't forget that's B. So negative 9 and negative 2 will work. Okay, so like with previous example, we'll have to build temporary factors because the leading coefficient is 9. So temporary factors. We'll have 9t minus 9, because that's the first number which we find, times 9t minus 2, because that's the second number which we find, equals 0. So temporary factors means that you have to check if you can factor GCF, and greatest common factor from first parenthesis, it's 9. So factor that 9 out. So we factor 9 out, so we have t minus 1 times 9t minus 2 equals 0, and you're ignoring that. So now we're going to solve for t, use zero product property, which means 2 minus 1 equals 0, 9t minus 2 equals 0. So we have that t, it's equal 1, and here we have t, it's equal 2 over 9. So don't forget that this is not your solution. It's a long problem. I do understand that. We use t only to convert our original equation, which has x to the power of 4, into equivalent equations using variable t. So don't forget that replace x squared with t. So technically what that means, that t it's equal x squared. So don't forget that we use that substitution. So when we know that t is equal 1, that means x squared is equal 1. When we're saying that t is equal 2 over 9, so that means x squared is equal 2 over 9. Okay, so now you need to solve your equation for x, which means take a square root of both sides, and you have x equal 1, x equal -1. And here we'll take the square root of both sides, and we're having x equal square root of 2 divided by square root of 9, which is radical of 2 over 3, and of course also negative square root of 2 over 3. So when you take the square root, you're having positive and negative solution. Look what happened. We end up with 4x values, which means 1, you can give an index, 1, 2, 3, 4. That means this system will have 4 points of intersection. Okay, so let me just list it that way. The first one, x1 equal 1. Then I have x2, the second x, it's been equal -1. x3, the third one is radical of 2 over 3. And the fourth one, it's negative radical of 2 over 3. So now what you need to do, you need to find the y coordinate for each point. So don't forget that our solution are the points x comma y. So when you have x's, you need to find y values, y coordinates. So we need to find all 4 points of intersection. So now we're going back to that long problem. Let's see, we use the substitution, and we know that y it's equal this right here. So I'm going back right here. Y it's equal 2 minus 3x squared divided by 2x. I would like to copy this if you allow me. No? Okay, so so it's y 2 minus 3x squared, y equal 2 minus 3x squared. Divide by what? What was over there? By 2x. By 2x. So we need to find that y. So we'll have the first, I will just label that so we know that which x matching with which y. So x with index 1, y with index 1 will be equal to minus 3. I'm replacing x with 1. So I have 1 to a second power divided by 2 times 1. Simplify. So that will give me that y1, it's equal 2 minus 3 divided by 2, which is -1/2. So I have the first solution, okay? 0.1 comma -1/2. So that's the first one. Let's substitute here. So this is the second one. We need to find y2. So y2, the equation of y, it's 2 minus 3x squared divided by 2x. So second y coordinate will be equal to 2 minus 3. Replace x with -1. Divide by 2 times -1. And you're having that y2, it's equal, the same thing, 2 minus 3 divided by -2, which is -1 divided by -2, +1/2. So our second point of intersection is -1, +1/2. Okay. Let's look for the third one right here. So again, y with index 3, it's equal to minus 3x squared divided by 2x. Here we'll have a little more algebra. So y with index 3, it's equal to minus 3. we're going to replace x with square root of 2 over 3. Square that, divide by 2 times square root of 2 over 3. Now our job is to simplify that, so we have y cube, not cube, y with index 3, it's equal, look what happened, that 3 and 3 can, oh, not yet, oh, I made the major mistake. Hope you guys didn't see that. 2 minus 3, first we need to bring that square root of 2 over 3 to a second power, so distribute that exponent to both. Radical of 2 to a second power, it's 2. 3 squared, it's 9. Over 2 square roots of 2 divided by 3. So number multiplied by fraction, you only multiply that numerator. Okay, let's simplify that more. So y3 equal 2, and then you have 3 and 9 you can cancel. So we have minus 2 thirds divided by 2 radicals of 2 over 3. So y index 3 simplifies, so we need to change that 2 to 6 over 3. Divide by 2 radicals of 2 over 3. Again, maybe I show my work way too details, but I want to make sure that you guys see from where the solution comes. So now we can subtract the fraction. 6 minus 2, you have 4 thirds divided by 2 radicals of 2 over 3. Now you need to simplify that. You have fraction divided by fraction. So use that shortcut, keep, change, flip, which means keep the first fraction, change division to multiplication, flip over the second fraction, which is 3 over 2 radicals of 2. Now 3 cancel, 4 and 2 you can reduce it, so 4 divided by 2, it's 2. So we end up with 2 over square root of 2. That's not the correct solution. Now we need to simplify. You need to multiply top and bottom by square root of 2 over square root of 2. We have to rationalize that expression, and that will become 2 radicals of 2. Square root of 2 times square root of 2 will be 2. Cancel, radical of 2. Finally, we have it. So the third point of intersection is x was radical of 2 over 3. Y is square root of 2. Now, the third point of intersection, you guys can just follow. Look what happened here. What I'm going to do, I'm going to use the previous problem right here, because we're going to replace x with negative square root of 2 over 3. So I'm just going to, hopefully you guys don't mind. Let's see if I can. I really would like to copy this, but for some reason, I don't know why it doesn't allow me copy. Okay, so what I'm trying to do, hopefully you guys change your notes, have everything in your notes already. I want to show you right here that for y4, it's going to be the same thing, but the only change is that we plug in a negative. Okay, so y4, okay, so I'm calculating. So then when we simplify, that still will be positive here. This part will be negative. So here it's correct. This part will be negative. This one will be correct. This one will be negative. Here it's the same. The only change will be that this one will be negative. And that will be negative. And that will be negative. So this is the only change, this sign. For y4, you will end up with negative square root of 2. Okay, so I don't want to do that work twice. And we have negative square root of 2 over 3 and negative radical of 2. So we have our 4-point of intersection. Okay, I know it's a long problem, but I hope that you guys can follow the steps and understand that in this section we're dealing with system of nonlinear equation and requires a lot of work, definitely. So I'm not going to graph that, but I want to show you on the PowerPoint how those 4 points of intersection looks like. Okay, so we have it, and oh, they didn't graph it. They didn't graph it. Okay, I guess the textbook PowerPoint got tired of that problem. Yes, they didn't graph it. I'm also not going to graph it. If you guys have TI-84s, you can TI-84 graphing calculators. You can go ahead, try to type them in, which is not so easy because to graph something like that, not sure. I think you will have to solve for X and Y. But we end up with 4 points of intersection in this problem. The remaining problem is the word problem. I'm going to skip that. You guys can go ahead, read it. That's for you. You also have a solution of that problem. It's the same problem in the textbook. At this moment, I'm going to skip it because on the final exam, I'm not going to assign this type of problem because I have to test you on a lot of other things. So I'm going to skip it, but if you want to, you're interested, so that's for you. You have one example of the word problem, which you can solve it using system of nonlinear equations. So thank you so much for watching. I'm going to upload the video for you guys, and also I'm going to upload the notes so you can follow those equations. Thank you for watching.